record. All right, so we're looking back at how do you do integer addition without a calculator. And the first problem was negative 47, excuse me, plus negative 73. And let me get my cute little pointer out here, the laser. And because I forgot to share this with edit privileges, we had to do a screenshot to write on for their group. Very clever way to go about that. So they just rewrote the numbers stacked, and 7 plus 3 is 10. Yep. And then 4 plus 7 plus 1 is 12. So they got 120. Now they have negative signs in front. Oop, I got a chat here. It got rid of the negatives at the end for the total. Oh, there should be a negative at the end for the total. Correct. Thank you for pointing that out. So there should be, come on, pen. There we go. There should be a negative right here, right? Okay. Yeah, we'll just leave it that color. So we started off with two negatives, we're combining them, we still have a negative. So this right here looks a lot like what I added for my own group 4, which is just me, where I just took 47 and added it to 73 and got 120, okay? So sometimes when I'm doing a problem like this one right here, I just kind of even skip the negatives altogether. I just say, hey, let's take 73, add that to 47, 7 and 3 is 10, carry the 1, 7, 8, 9, 10, 11, 12. So this answer is negative 120 because it should keep the same sign, okay? So just kind of curious, do any of you, when you write it on paper, ever write it without the signs and then just put the sign back in?
That's actually how we did it in the beginning, and then we switched it.
And then you put the negatives in there? Yeah, and some people do write it this way with the negatives. Other people write it, you know, just positive, but realize the answer has to be negative, okay? So I'm just gonna add a little text note here. The answer should, oh, I didn't mean to be all caps, didn't shout at you, sorry about that. The answer should be negative.
We did have a quick question, I don't know if it has really any bearing right there. Is that would elementary school kids at this point know that a positive negative would equal a negative at this point?
Yeah, so what's happened in the school at this point with the kids is, let me switch back to my other screen here, is the kids spent a lot of time either playing on a number line or playing with chips or charged particles, and then they just start to see, oh, check it out. If they're different signs, one thing happens. If they're the same sign, something else happens. So they have been learning this. Now, and that's what we're trying to get at right now. What's the rule? Why does that happen that way? And we're getting to that because we did a whole bunch of super simple examples. Like what happens when we take negative 3 plus negative 4? Why is the answer negative 7? Well, it's negative 7 because of the way the number line works, or it's negative 7 because of the way the chips work. And that is the way we started off. So let me get back here, finish my explanation. The answer should be negative because the add-ins are both negative. So this requires a little bit of explanation there. And I would say that the group 1 problem is most like the group 4 problem I added here. Except here, both add-ins are positive, so the answer is positive. So if they're the same sign, the numbers we're adding, it's pretty straightforward. If it's not the same sign, it's not as straightforward. So let's look at the other two groups and see what they did. Group 2, okay. So group 2 had negative 47 plus 73, and they took 73 and subtracted 47 and got 26, and I think that's it. So they're claiming that based on this work right here, negative 47 plus 73 equals positive 26. And that's it. Did I miss anything on that? That is the right answer, I agree. Is there anything else I should say that you guys want to add? Group 2. Okay. All right, so that seems pretty straightforward. So we did have to kind of rewrite this. We didn't just take it as we saw it. A common mistake here. So I'm just going to write this on a, I guess I'm going to leave it in the Jamboard. Just move this and switch colors. So common error here is to try and take it as it's written and try to do something like that. And say 7 minus 3 is 4, but then we've got 4 minus 7. What do we do with that? That's kind of weird. And some kids will try to do that and make a mistake and then realize, no, that's not right. Why didn't that work? So I think this is interesting, like this error that is pretty common versus the way it got done and led to the correct answer there. Let's look at the next group and we'll come back and talk about this. All right, so the next group, let's see, they stack the numbers 73 minus 47. Okay, so that's interesting. And then, let's see, 73 minus 47. Yeah, just like before, that's 26. But then they changed the sign to negative since 73 is quote, I love that, quote bigger. All right. Yeah, so the quote bigger thing, that's a tough one. Like what does bigger mean? And so we definitely have to figure that out. So I agree, quote bigger is a good idea, quoting that. So the claim here is that 47 plus negative 73 is negative 26 as the result. Interesting thing here I just want to point out is what they wrote here is exactly the same as what this group wrote here. There was just a slightly different decision at the end for whether the answer was positive or negative. Okay. And here, I guess we could say, if I put it in text to kind of match what group 3 wrote, the answer is positive since 73 is, quote, bigger. I love that. Cool. And back to Amanda's question, like, how do the kids know this? And the question, the point is here that they kind of have a hint of it because they did so many little examples, like over and over again. And we'll look at some little examples to confirm this in a moment. So we gotta get better at the bigger thing, like bigger, smaller, greater, less. 73 is definitely greater than 47, if I'm using greater in the technical way we talked about it last chapter. Over here, though, negative 73 is not greater than 47, but in a sense, it is bigger. So what do we mean by bigger? Can we be a little bit more clear? Anybody want to take a shot at that? Oh, Monsi did. Okay. You have more on the negative side than the positive. Oh, that's awesome. I love it. Yeah. We have 73 is more on the negative side than 47 is on the positive side. Other ways to state that. So I'm gonna mess with your slide here by typing some stuff. I'm gonna grab what Monse said. Can I copy and paste into a Jamboard? No. You have more positive, negative side, excuse me. The positive. All right, so that's one way we could put it. Anybody have a different way to put that? Either chat or speak. Give it just a few more seconds, then I'll throw in an idea. Okay, so another way to put that is Am I in the box? There we go. Ooh, how'd that get so big? I have no idea how I did that. I don't like that. Start over. Did I hit the wrong button? There we go. All right. Negative 73 is farther from 0 than 47. That'd be another way to put that. So by bigger here, technically we mean farther from 0. Okay. Which gives us more on the negative side than the positive. Totally agreed with that. And so this one back here, 73 is bigger, it's further from 0. So I'm going to add that in here too. 73 is further from 0 than negative 47. And now thinking back to the chips, right, there are more positive chips than negative chips. So when we combine, the answer ends up being positive. On this one over here, if we had chips, there are more negative chips than positive chips, so the answer ends up being negative. So we can relate that back. So let's just put that in here too. There are more negative chips than positive. See what I'm writing. There we go. Positive chips. So the combination is negative. And I think within a Jamboard I can copy and paste. Let's try that. So back here I can add to this. Ooh, that's not what I wanted to have happen. All right, I guess I need to retype it. There are more positive chips than negative in this case. Because we've played a lot with those chips with the kids at this point, and we get used to that. Some chips cancel out. So we have more positive chips, the answer is going to be positive. Over here, we have more negative chips, so the answer is going to be negative. All right, so now we need to turn this into rules. And I think I'm just going to get this started a little bit and have you guys help me finish it. So we have our subtraction algorithm. Now we're trying to write up the addition algorithm for integers. And we ended up having two types of things happen. One type of addition was just an addition, but the other type of addition turned into a subtraction. Right? So case one, I'm going to say the numbers have the same sign. And then we'll describe what we do. Leave some space. Case two, the numbers have different signs. And then we have to write down our steps. What do we do in case two? There we go. So case one, what did we do when the numbers have the same sign? Somebody help me out here. Either chat or speak.
We combine them.
Yeah, we actually added, right? Okay, so that's part of it. So add, and then what? How do I know if the answer is positive or negative? let's go back and look at the Jamboard. So group 1, you said you originally started off adding 73 to 47 without putting any negatives in there and just threw the negative on the answer, and then you rewrote it to have negatives in there. Okay. So I think,
That's correct.
go on, okay.
Oh, I just said, yeah, that's correct.
Okay, so which is a lot like, so here you started with 2 negatives, but you added 2 positives, kind of like I did in my own group 4 here. I just added the 2 numbers, right? I'm used to doing that. I combined them. Does anybody know a phrase that means the same thing as distance from 0? Monty says the sides stay the same. Yeah, and that was the answer to my earlier question about what happens next. How about distance from 0? What's a phrase that means distance from 0? It was in the reading, but I haven't talked about it in class yet. All right, hopefully somebody comes up with an answer for that soon. I'll await that while we go back here. So we did an addition here, right? So that was like part 1 of case 1. And then 2, the sum had the same sign as what we started with. Ah, thank you, Amanda. Yeah, absolute value. So essentially what we did here is we added the absolute values. Because we ignored the sign when we added them, right? Those positive numbers are positive, I added them, okay. But the negative ones, we kind of think about it as 47 plus 73, we get an answer, and then we make it negative. So it's kind of a 2-step process in case 1. So we add the absolute values, and then the sum has the sign of the original numbers. Sum, or as Monty put it, the sum has the same sign. Thank you. All right, so let's figure out case 2. Case 2, the numbers have different signs. So that was group 2 and 3. So group 2, they had negative 47 plus 73. They wrote it as 73 minus 47, got their answer because they know how to do subtraction that way, and said the answer was 26. And we decided lots of ways to state why. Group 3 had 47 plus negative 73, but in the subtraction, they did positive 73 minus positive 47. Okay. And then they decided the answer should be negative because negative 73 was, quote, bigger. And there's a lot of different ways to describe what bigger means. It is different than less than and greater than, right? Because negative 73 is definitely less than 47, but it's farther from 0. So in a sense, it's bigger, okay? The bigger number dominated and we kept its sign. So we got to write that up in a series of steps now. So I'm going to have you help me do that. Again, regardless of which one was negative, the subtraction happened as 73 minus 47. 73 minus 47. And that's important, the way we went about doing it. That's our algorithm. But how do we describe that algorithm? So let's see, we did a subtraction. We also had to think about absolute values because we kind of ignored which one was negative at first. So I guess I might say 1, consider the absolute values of each. Now I'm not going to call them absolute values with kids. I'm doing that because you guys are adults. Can't spell. So we consider the absolute values, and then we do a subtraction, but it's not any subtraction, right? Because remember the error I started to make when I was doing that? I'm not going to take 47 minus 73 because that looks weird, and our standard algorithm does not, can't do it, right? Our standard algorithm can't handle that. It doesn't work right. We need a different algorithm, or different, yeah, algorithm. And we did a subtraction, but there was something special about that subtraction. I can't subtract in any old order. Does somebody want to tell me about how we chose to do the subtraction?
We have to subtract from the number that's furthest from 0.
Yes, that is correct. Good job. Yeah, that is important. We want to, and again, we got to consider distance from 0, right? The idea of, quote, bigger, right? So so there's 2 ways to do that. One way is the way Amy mentioned it. One way is to say, if we're considering the absolute values, we just subtract the number with the smaller absolute value from the number with the bigger absolute value. So a whole bunch of different ways we can word that. So since I wrote subtract, I'm going to write subtract the smaller absolute value absolute, there we go, from the larger. Absolute value. Then, right, we're not done yet. We have to decide what sign the answer gets. And it goes with the sign of the, quote, bigger number, which we're now talking about in terms of absolute value. So then the sum gets the sign of, we could say the number that was further from 0 or the number with the larger absolute value. So a couple ways we can word that. And again, I'm going to go with the absolute value version. The sum gets the sign of the number with the larger absolute value. Okay, so we're going to apply these in just a second and make sure they work. But it turns out this is the addition algorithm. It's kind of complicated. The subtraction one gets to be a little easier because it says, hey, just make it an addition and then do this. And we have a way to make an addition. But addition of integers is actually pretty complicated. And if you think about, like, when you were in an algebra class, the most common type of mistake is messing up the sign of an addition or subtraction. So that's the algorithm. It has 2 cases. Each case has a series of steps to follow, and then we come up with the answer. So I just want to demo this on a different set of numbers. So let's try -86 plus 23. So with this one right here, they're opposite in sign. So that's case 2. So I want to consider their absolute values. So now I have 86 versus 23. And we don't write all this down, but this is kind of the way the thinking does. And then what we do is say, okay, 86 is bigger, so then we rewrite it as 86 minus 23, and 6 minus 3, 8 minus 2, and then we say, all right, 86 was farther from 0, right? It's bigger than 23, so that means the answer should be -63. And often, right, we whip out a calculator to do this, but we don't have a calculator. We can kind of say, well, the negative is further from 0, so the answer should be negative. 80 minus 20 is 60s. So yeah, that seems like a reasonable answer there. Okay. And we usually write less than this. So if I were given this again, and I had to come up with an answer, I'm probably going to rewrite underneath or somewhere nearby this, do the subtraction, and then say, oh yeah, but it's negative. Right. So that's applying the algorithm. I consider the absolute values, I subtract the smaller absolute value from the larger, and then I decide whether the answer stays positive or gets to be negative. In this case, it gets to be negative. The addition algorithm. And again, an algorithm is just a series of steps. Just for a sec, I want to look back at the error I started to make earlier on that Jamboard one. So let's go back to the Jamboard in this error here. If I consider a different algorithm, let's see. Actually, I want to do that maybe on the next one. Yeah, let's try it on this one right here. If I'm used to that algorithm about subtraction, that addition is adding the opposite, I could, sorry, this. There we go. Pick a different color. Let's go with blue. I could say this is the same thing as 47 minus 73, and then I could try to stack it as 47 minus 73. Unfortunately, our standard algorithm isn't designed to do it this way. The standard algorithm has to have the larger number on top. But there's another algorithm that actually does work here, so check it out. Switch color. 7 minus 3 is definitely 4. But here I have 40 minus 70. Anybody want to tell me what 40 minus 70 is now that we know signs?
Negative 30.
It is indeed negative 30. This is what we call the absurd algorithm where we use negatives. And then to reconcile the difference, I have 4 combined with negative 30 is going to give me a negative 26. And so I can still get the right answer, but I had to switch to the absurd algorithm to get it. So again, I mentioned before, all algorithms have their pros and their cons. We happen to have this one we call the standard one. Its technical name is the borrowing or renaming algorithm. But the absurd one comes in handy here if I rewrite that addition as a subtraction. Okay, so we've had a little bit of fun with addition and subtraction. I think I'll do one more example and then we'll talk about multiplication and division. So let's read